Hello and welcome back to NTMAU. This next problem is problem number 314-116. And in this problem, just as in any of the other problems in the past, what we want to do is go for what we know. Now we know that we've got a distance from this point here all the way straight up to this point up here. And what they're looking for is x. That's this distance here. So this is going to be key for us, this distance here. It's going to be very important that we understand where that's coming from. So what we want to do is build angles around that. So anytime that I have two radiuses that intersect each other, you know that that's going to be a hypotenuse. So from here to here, that would be hypotenuse. From where this 3.8 connects to the 2.2, that's going to become a hypotenuse as well. So the 2.2 is going to probably come right up to about here, pretty close to it or whatever else, so that it comes a straight line. So this might be the tangent point right here for this, since it's coming straight down from this center line to this center line. Of course, this has to swing out to be 2.2, and it probably breaks right there. And then it continues on and around over here like this, where this one's at 3.3, and it would continue out a little bit further, and it would just keep on going that way. So you kind of get the idea. So these are center line points. What else do we know? Well, we know that we've got a distance from this point up to here of 1/4 of an inch, and a distance from here to here of 1/2 an inch, because this would be drawn straight down. So this 1/2 inch radius right here would be from the center point to here, and this 1/4 of an inch radius would be from the center point up. So 1/4 of an inch plus a 1/2 inch to here is going to give us 3/4, and then this 1/2 inch radius again coming in here, and the 3/4 will give us 875. So I'm going to sketch those up and give you a little idea of what this looks like. Okay, so what we're looking at with this angle here is that we know that we've got 2 inches from here to here, and we have 1 inch 625 thousandths from here up to here. So 2 inches minus 1 inch 625 equals 375. So it's 375 thousandths from here to here. And we know that we've got the 1/2 inch radius here, which is what this one here says. This is a 1/2 inch from this point to this point. And we have 375 if this would swing all the way around. So we've got 375 from here to here. So 375 plus a 1/2 inch equals 875 thousandths. And the 375 thousandths here. So now we have a hypotenuse. And, well, we would have an opposite side, if that's what you wanted to call it, if we put our angle right here. But what I'm really going for on this one is I want to know what my distance is going to be from this point here to this point here. So that's what we're looking at. All right. Let's go ahead and move on with that one. Okay, so looking at this, we come up with 790 and 6/10. And I'm going to call this angle A, or at least this whole triangle angle A, just for a reference point. So put somewhere down on your paper, A equals distance here of 7906. Maybe even sketch it out, or just kind of remember it. Hope you printed out these things, or if you have the printout, that you put this angle in there. All right, let's go on to our next one. With our next one, I'm going to break this down into a couple different things. The first thing we know is that we've got a distance from here to here of 5 inches 200 thousandths, okay? That's the overall. Then we know that we've got 790 and 6/10, and we also know that we have this 1/2 inch up here, this 1/2 inch that's right here, okay? So if we take this 5 inches 200 thousandths minus this 1/2 inch minus this, we would then come up with a distance of 1 inch 709 and 5/10. Okay, so, oh, and we would also want to subtract this 2.2, so we would get 1.7095. So let's go ahead and sketch that one up. Okay, so again, the 5.2, that's this distance right here, that's right here, minus the 790 and 6/10, that's that distance right there, minus the 2.2, 2 inches 200 thousandths, and then minus the 1/2 inch that's over here or up here. That gives you the 1.7904, or 7094, 1.7094. Okay? All right, let's go ahead now and let's solve for both this hypotenuse here And also let's solve for this leg right here. Don't know if we're going to need it or not, but let's go ahead and solve for both of those. Okay, so looking at this, I'm going to come up with a distance from here to here of 1 inch 625 thousandths. That's from there to there. And I'm going to come up with a hypotenuse here of 2.358 and 6/10. And how did we get these? Well, we know that we've got the 1.625. That's already given, so we don't really have to do a whole heck of a lot about that. That's a given dimension. I just put it out over here. And I knew what this side here was, so all I really had to do is go a squared plus b squared. So this would be a squared plus b squared equals c squared. Okay, that gives me that hypotenuse. Okay, I'm going to get rid of some of the clutter. I'm going to take out some of this math formulas, or at least the math figures, and we'll just put in some angles. So I want you to mark these down right now, and then we'll put in some angles from there. Okay, so what I've done is I've created this triangle right here now. And what I know is I've got 5 inches 200 thousandths from here to here. And I have 1 inch 290 and 6/10 from here to here. So I'm going to take this minus this 2 inches 613 and 9/10. That's going to give me this distance up here. So again, this total length right here, all the way across, minus this piece right here, this little bit here, and then minus this here. That's going to give me the distance from here to here. Then what I'm going to do is I'm going to extend this all the way out. Now I know that I've got 43 degrees, 0.549 and 5/10 decimal degrees. This is a decimal degrees, and I know that because I figured this 46 degrees, 45 decimal degrees out here. And I got that because I knew what this was, this length here, the 1.625, and the 1.7095. So that's 46 degrees, 0.45 decimal degrees, and this is 43 degrees, 0.55 decimal degrees, okay? So I put this in here, and I subtract it from 90. All right, I hope I'm not going too fast, but I put this angle inside here because I figured it out. And I subtract it from 90, and I'm going to come up with a 43.5495. That's the distance from here to here. Now what I'm going to do is I'm going to extend this just a little bit farther, and I'm going to drop it right down to here. So you're going to get another triangle inside here. And what that's going to do is if I took this 2.613 and 9/10 and subtracted the 2.2 from it, that's going to give me the distance here. So I take this and add it onto this. Let me just go ahead and do it so that it kind of... Okay, so what we're looking at here is we know that we can have a distance from here all the way up to here of the radius that we have inside here, that full radius, which is what, 3.8, the radius? Yeah, so the radius from this point to up to here is 3.8. And then what we're going to do is we're going to subtract this radius from it, and that radius there was 375. So if we take 375 from this radius, which is this radius here, from the 3.8 all the way down, that's going to give us 3 inches 425 thousandths from here to here. Then when we come across here, we have this distance from here to here, which is 1 inch 295 and 5/10. Okay, so we're actually creating another angle inside here, which is just a continuation of this purple one. I just didn't figure it all the way out yet. And then what I can do is I can solve for this angle inside here, from this point all the way over to this point. All right, and all you're looking for is the adjacent side. Okay, because you're going to use the adjacent side and you're going to use the hypotenuse to come up with this. And when you do that, you're going to come up with somewhere around 67.77 or something like that. I'm not 100% sure. Actually, it's 67.9007. So let me put this over here. I'm going to sketch this out. 67.9007 degrees, decimal degrees. So that's this angle from this point all the way to this point. So this would be still the purple angle here, this one right here. Okay, so you got that. Now What you can do with this now is solve for this total length from here all the way down, because you could actually go c squared minus b squared to equal a squared. That would get you it all the way down as well, but either way you want to do it. Okay, and you're going to come up with this total length here. This total length then is going to equal, and let me just sketch this out here real quick for you. This total length from there to there, and this isn't a nice straight line like some of the other ones, but you get the idea, would be 3.1705. Okay? So that would be the total length of that magenta, this is magenta color here, this magenta angle going straight up and down. Okay, so that's that. Then what we have is we know what this distance is from here to here, and we know what this angle is inside here. So all you have to do is solve for this distance from here to here. And when you do that, you're going to, and you actually know what that is already. So if you take the 1.625, because it's 1 inch 625 thousandths, and subtract it from this overall length, that's going to tell you what's left over from here to here. Okay? And that size, when you do that subtraction from there to there, is going to equal 1.5455. That's this here. Okay? And right there. 1.5455. All right. So all you have to do then is, you know that this total distance from this point all the way up to the very top here is the 3.8. So if this is 3.8 all the way from here, that's the radius that's swung all the way out, then all you have to do is subtract this from it, and that gives you your answer. Okay, so 3 inches, 170 and 5/10, minus the 1 inch 625 is going to give you the 1 inch 0.555. Once you have this 1 inch 0.5455, all you have to do is take that and subtract it from the total diameter all the way up to the top, or radius I should say, all the way from the top, and you have x. So your answer x, 3.8, let me make this big and minus 1.5455, and your answer would be 2.2545. And that equals x. Okay? I hope you understood it. If you don't, go ahead and watch it again. And if you have any questions, just give me a holler. Thanks, and have a great day.